Someone took the most expensive model on the planet, distilled it into something smaller than a single high-resolution photo, and put it on your watch. Okay, so here's the setup. A London startup called Cactus Compute, 8 people, fresh out of Y Combinator's summer 2025 batch, released a tiny model named Needle. It's distilled from Google's Gemini 3.1 flashlight, and it does exactly one thing, function calling, the bit where a model reads your tools list and figures out which one to call. They open sourced everything. Weights, dataset generation, training code, all on GitHub under MIT license. The architecture paper that ships with the repo is the actually interesting part though. They removed something fundamental from the transformer. Look at what shipped. The README opens with the pitch, what they call a simple attention network, fully fine-tunable on your laptop. Then there's this absolute monster of an ASCII diagram showing the encoder stack feeding into a decoder, no FFN anywhere, gated residuals, cross-attention from the encoder, pre-trained on 200 billion tokens across 16 TPU v6 chips, 27 hours of compute. Then post-trained on 2 billion tokens of synthetic function call data, just 45 minutes. Quick start is 3 lines, clone the repo, source the setup script, type Needle Playground. A local web UI pops open, waits, auto-download, and you can fine-tune on your own tools right from the browser. There's a Python interface too, and a full command line with 8 subcommands, including one that just spins up TPU management. Function calling is a crowded space. Google ships function Gemma 270M, Alibaba ships Qwen 0.6b, IBM has Granite 350M, Liquid AI ships LFM 2.5. All of these are small models, all targeting the same problem, picking which tool to call from a structured list. Needle is the smallest by a meaningful margin, 270 million parameters down to 26. The repo straight up names competitors in the README and claims it beats every one of them on single-shot function call. Cactus also makes the actual mobile runtime that lets you run Needle on phones and smartwatches at 6,000 tokens per second prefill, 1,200 tokens per second decode. That is comically fast for an edge device. Pin the receipts, 26 million parameters. MIT license, 1,700 stars in 3 days, 726 points on Hacker News. Here's the part the paper is actually about. Standard transformer blocks have 2 pieces, attention, then a feed-forward network. The FFN is roughly 2/3 of the parameter count of any modern transformer. Cactus did experiments and concluded that for tasks where the model is reading from an external knowledge source, like a list of tools, you can completely drop the FFN. Their reasoning is that function calling is just retrieval plus assembly. You match a query to a tool name, you extract argument values, you assemble JSON. That's 3 things attention is already good at. None of them need per position feature rewriting, which is what FFN gives you, so they cut it out entirely. 12 encoder layers, 8 decoder layers, embedding dimension 512, 8 attention heads, 4 key value heads, and 0 FFNs anywhere in the graph. Removing the FFN breaks a few things, and the paper walks through the fixes. Without FFN to do per position, rewriting the standard additive residual connection gets too weak, so they use gated residuals where each layer learns a scalar between 0 and 1 for how much of its attention output to keep. They swap normalization for zero-centered RMS norm, which initializes as identity. They run 2 optimizers in parallel, muon on the QKVO projections to keep weights orthogonal, ADAMW on everything else. They train with fake INT4 quantization every 100 steps, so the model learns to be robust to the 4-bit weights it will actually ship with. And they weight the loss differently per token argument values get 4 times the gradient signal of structural tokens, because that's where the model actually messes up. Running it is genuinely 2 minutes. Clone the repo, source the setup script, which builds a virtual environment and installs dependencies. Then type Needle Playground. That last command opens a local web UI on port 7860 and downloads the weights from Hugging Face automatically. You point it at your own tools list, type a query, see what the model picks. The Hacker News thread is the part that surprised me. 206 comments deep, and they're not the usual hype. One tester typed, "I need to contact my boss, I will be late," and the model picked set timer for 20 minutes instead of the email tool. Another reader hit CPU errors trying to run it in an unprivileged container. A computer science professor showed up to say one of their students independently reproduced the same no FFN finding on QN this same week. And Henry from the Cactus team is in the thread, replying personally to almost every comment. They also shipped the full data generation pipeline, so anyone can rebuild the training set from Gemini if Google revokes their key tomorrow. Real talk before you wire this into anything. One decision per query, no multi-step reasoning, no conversation. Ambiguous prompts where the right tool isn't obvious from the last sentence remain genuinely hard at this scale. So who is this for? Hardware builders shipping a microphone in something the size of a pebble. People putting voice into glasses, kids' toys, doorbells, watches, anything where round tripping to the cloud is dead on arrival. Watch what the team distills next. If the same architectural trick works for vision or coding, the hardware roadmap for half the industry shifts.